As you can see, we have a rather distinguished cast. If you've been in the software field for a while, you're probably familiar with these names. Sometimes though, I'll wonder whether going down the panel, they might be more interested in being known as a motorcycling enthusiast, windsurfing enthusiast, a mother-to-be, a sailor, and I guess a diver, right? But in their spare time, they also have something to do with developing software technology. So in alphabetical order, we have Rick Cattell from Sun Microsystems, who was the chairman and founder of ODMG, if you're familiar with object databases. He also was the original enterprise Java architect. We also have Don Chamberlin on the panel. He's to my immediate left. And Don is a longtime IBM database researcher, or let's say an IBM researcher, particularly in the area of database and languages. He was the co-inventor of SQL, and more recently, he has teamed with a couple of other people to create something called Quilt, which was kind of the core of the XML query language. Daniela Florescu, or Dana, in the center, was one of those two other people who helped develop the Quilt specification. She's the CTO, or Chief Technical Officer of XQRL Inc. Then on her left is Jim Gray, who is with with Microsoft Research here in the Bay Area. Jim was with IBM at one time, and I guess that sort of stuck in my brain. He's sort of wrote the Bible on transaction processing. He also was the 1999 ACM Turing Award winner. And on the far left, the diver we have with us is gentleman Jim Melton, who is well known as an author of a number of database books. He also has been for 15 or 16 years now the editor of the International SQL Standard. And more recently, he's also been focusing on an initiative called SQLX, which is to bring XML and SQL together. So obviously, we're going to be talking quite a bit about the future of software and databases, but as I mentioned to a couple of panelists, I originally was just going to put up one slide with names and then go from there with questions, but I overheard a conversation and got involved in it a few days ago that made me realize that a lot of people in this field probably don't have any idea where we came from. So I thought maybe I'd set a little bit of context, why do we have database technology, for example. So you can see here in the early years, depending on your reference source, either 1952 or 1954, we had the first installation of a commercial computer, something in industry, outside of the academic halls, outside of military. 10 years later, we had 13,000 non-military computers valued at over $4 billion, and roughly, in those days, the average price of a computer was over $300,000. But one of the other key influences is that at that time, we were doing primarily application-managed data stores. In other words, applications weren't really built to share information or data with other applications, and they all had their own data model. Oops. Hit the wrong button. That's the trouble with having the light in your eyes. I should have a little light right here. So anyway, I guess one of the obvious questions, which a lot of people may not be aware of, is why were there so few computers in that day? And fundamentally, you can see that the monthly rental on a computer, even a medium-sized computer, was close to $20,000, between $12,000 to $20,000. For example, if you wanted to buy core memory, 2K of core memory was $102,000. If you wanted to purchase a medium-sized computer like an IBM 1410, it was over $730,000. And then, this was the choice that Midwestern Bank was looking at for running a trust accounting system in 64 through 68. And again, you can see that the monthly leases are all up there, much higher than we would expect if we've only been in the computer field in the last few years. And you can also see that the price to buy was typically about $500,000. The other thing that's interesting is that in those days, it was not unusual for hardware to cost more than people. In other words, for example, in 1962, there was a tool company with $55 million in sales, and they actually spent $1,000 more that year in their budget for hardware than they did for salaries. And of course, they spent $90,000 for 9 people. The other thing to notice is that a company like International Harvester, which was doing over $1 billion in business, was spending only about $3 million in computer costs. So then, one of the major milestones in the field is that in 1964, American Airlines went operational with the Sabre reservation system. And that actually was the first very large-scale commercial application. And it had goals such as delivering 3-second average response time and process. Now, the interesting thing is it did that with 2 computers. One was actually a hot backup, and the primary computer had 64K of memory. And in those days, the 700 million characters that it could store was staggering. It also was written in machine code, 500,000 lines of machine code. Now, the other interesting thing, which I think people would be staggered by today, how many of you could go into your management and say, I want to develop this application, and it's going to take us 10 years to bring it on the air? So there's the timeline for Sabre, 1954 to 1964. The other thing is that, in 1964, it was not unusual if you had a card-based operation doing your accounting to take several days after the end of the month to go ahead, for example, and close out inventory. So it was 5 days to have that information available, and that's processing about 80,000 orders. So in the 1960s, the economic situation was that large systems were very expensive, over $50,000 a month. Software was almost all custom programming, and that was expensive. Development cycles were very long. We primarily ran batch operations, which meant it took quite a while to get information. In other words, we didn't really have timely information on a daily basis. And we had a scenario where we had ad hoc data stores managing our data, which made it very complicated to do data interchange. And doing data interchange often involved writing custom software. So these were some of the influences that led to the development of database technology. One of the key things, or the key message is, computers are expensive, custom programming is expensive, so it's very expensive for us to create this information, to gather this data and create this information. Why don't we go ahead and share some of this and share some of the expense across departments? So the concept emerged of shared data banks. In fact, if you remember reading Dr. Codd's original paper on the relational model, it had to do with shared data banks. Eventually, that terminology evolved to databases. The other thing is that since 1964, of course, another major influence is we've seen tremendous reduction in price of computers. We've gone from $730,000 for a 20K computer to a server that my company just bought recently with 512 megabytes of RAM and a RAID array was $1,600. So you can see there's been a tremendous decrease in price. I'm sure we all wish that cars and homes and other things in our life had gone down that much. Memory prices also have an influence on databases because now we can put a lot of memory into database servers, and we can do things like create in-memory databases. And again, 2K cost you $102,000 in 1964, and now you can buy 128 megabytes for $34. So in the past, I've had this problem of trying to relate to people the cost of computing because, how do you understand $1964 versus like year $2,000 or year $2002. And what I did a few years back was I created something called the Mustang Index. The Mustang's been around since 1964, so it's easy to quantify the relative cost of computing if you compare it to the Ford Mustang. And you can see that the IBM 1410 cost you 310 Mustangs in 1964. And today, it's 0.089 Mustangs. So again, we've had tremendous benefit from the reduction in hardware. Also, we also have things now like componentized software. We have packaged software. We also have cost-effective networking now, so we can actually have distributed data instead of having to have a central database running on a central computer. So what are the influences that we have to look at for today and tomorrow? Well, obviously we're going to continue to have commodity hardware that will enable us to have things like in-memory databases. Right now, it seems like everybody's looking at a model where the database is kind of reached by the browser, or it's behind the browser. In other words, the browser is becoming pretty much a universal client. We also have widespread distributed computing and can expect more of that as we have cheaper broadband. We have XML, and we have several people on this panel who've been involved very extensively with XML. We're working very much on a model for collaborative internet applications and web services. And again, that's creating distributed components that can communicate using XML messaging. We're also looking at having ubiquitous connectivity and widespread adoption of wireless technologies. A lot of analysts forecast that, in the next few years, there'll be 2 billion people with some sort of personal communications device, smartphone or whatever. So 4 decades after the scenario I first showed you, what are we looking at? Well, now we have hundreds of millions of computers. Recently, it's been announced that over at Stanford Linear Accelerator, we probably have the world's largest database, 500 terabytes. There's a banking system in the UK that has a database application, of course, that is capable of sustaining 400,000 concurrent connections. And that number is 18 months ago. I don't know what it would be today. We also have commodity hardware. Just a few days ago, I ran a 50,000 row select on that $1,600 server and got back 50,000 rows in 1.15 seconds. And we also have the capability now of parsing 2,000 to 3,000 XML documents per second. So what we want to talk about during this session is, well, what can we really expect between the next 5 to 8 to 10 years, 2007 on out? Again, given we'll have billions of connected devices, people wanting to use web services and access databases. We'll probably have video on demand. We'll have voice recognition. Again, these things will be ubiquitous. In the 60s, the RAND Corporation forecast that by 2010, we would have bioelectrical input or bioelectrical links to computers. Kind of looks like we're on track to do that. And we may even have pocket storage of terabytes. So again, we have this expert panel who is going to provide us, hopefully, some insights into some of these questions. These are some of the things I'm hoping we can cover during the session.